My name is Klas Lindfors. I work for Yubico as a software developer. We have one big product, the YubiKey. Let's try there. How many, show of hands, how many have heard of the YubiKey? Very good. How many have a YubiKey? Good enough, I guess. So you know about the YubiKey, the product we have. So we're a Swedish startup. I'm sure you know that. We are about 20 people, presence in Sweden, UK, and US. We build the YubiKey. It's a keyboard. The standard YubiKey is a keyboard to the computer. You press the button and it types. We've got a few big name customers over the last year, basically. We have Google as a customer. We have Facebook as a customer. So, what will I talk about then? One-time passwords I started with. What is there? What are there for alternatives in the one-time password world? How does it actually work? What makes it one time? And where do we at Yubico think we will end up in the future of one-time passwords? And hopefully I won't take too long to say this, so we'll have time for questions. The algorithms in place today, oath HOTP, somewhat. Oath TOTP, yes, definitely for one-time passwords. And Yubico OTP. And there are others. These are the more used algorithms. HOTP. HMAC-based one-time password algorithm. So, okay, so what is it then? Yeah, it's typically that, or it was typically that. A token showing, at the press of a button, showing a 6-digit code. It's event-based, so every time you press the button, the code will change. It requires counter synchronization. The server and the token has to have the same counter. The good thing about it, it's standardized. It's an RFC. It was standardized by the Initiative for Open Authentication. Details, boring details, some might say. It's an HMAC SHA-1 of an 8-byte counter and a key that is truncated down to 6 or 8 digits. And it's truncated by taking the 4 last bits as a reference into the 20-byte answer. But that's just details. It ends up with a 6-digit, typically 6 digits, or 8 digits if you wanted to. Am I going through these too fast? No? Good. Too slow, maybe? And quick example, key in hex. The counter, HMAC SHA-1 of that ends up in a 20-byte hash. Take the last as a reference into the 20 bytes, get that as hex, take that modulo 1 million, and you end up with a 6-digit code. So, the tricky thing with HOTP is the counters. Always the counters. You have to decide on how many counters into the future might the token be. Do we accept 3 into the future? Or is 10 okay? If 10 is okay, then there is an awful lot of correct guesses just from guessing. So you start with the stored counter plus 1, you generate codes until you find a matching one, or you don't find a matching one. One of the boring parts of that is that you have to do that for each token for the user. So if the user has 3 registered tokens and you have a window of 3 counters, then you might generate 9 acceptable answers to that. Yeah, and when you find a counter that match, you store the new counter for that. It requires synchronization across servers if you have several authentication servers, and it requires a reset when and if the user has pressed the button to show that it generates different numbers every time. Could become support intensive. So someone came up with TOTP, time-based one-time password algorithm. It's an extension of the HOTP that instead of a counter uses current time. It's also standardized as an RFC. It requires time synchronization, which might be a problem for some. It's very much the same algorithm as HOTP, but uses current time instead of a counter. And it uses, typically, the standard allows for very different use cases, but it typically uses seconds since 1970, January 1st, divided by 30 as the challenge, or as what time is now. And it's the same algorithm, so nothing different there. And again, an example. It might not say a lot, but take current time. Well, we're 40 minutes after that time, but you take that time, divided by 30 and get a challenge. Use that as the challenge for, or the message for the HMAC SHA-1. Get an answer, use the last 4 bits as a reference, get a hex, and you do that model of 1 million to get a 6-digit number. Here we have the how much time might the token differ instead, which is always a tricky issue. For hard tokens, especially for cheaper variants of hard tokens, you will probably have time drift. So either you have a way to resynchronize the token's time, or you might have to track the time drift of the token individually in a system, which is an interesting challenge when you start having a large deployment and calculating time drift. One of the big upsides of TOTP is that you don't have to track a counter that's changing all the time. You can have several validation servers, all they need is time. And maybe that database of time drift for individual tokens. But with the nowadays more common smartphones, you don't have time drift in that way. Though I've noticed that Google has added to Google Authenticator that you can synchronize the time in it so it remembers its own time drift, which is a way to get around that, I guess. Yubico OTP. I'll mention a few things about it. It's also event-based, so it's similar to HOTP in that way. It's not based on HMAC SHA-1 at all, but on AES encryption. It's not standardized at all, which is, for some use cases, a big downside of it. An upside of it is that it contains an ID already in the OTP. It's a 44-character OTP typed by the YubiKey. I should have had an example here, but I don't. It contains 2 counters, originally to decrease flash wear on the token. It's 1 counter that counts up every time you insert the key into a computer, and 1 counter that counts from 0 from power up for each button press. It's got a lot more stuff inside it. 16 bytes inside 1 OTP. That gives it 32 characters, or 16 bytes on the other side when encrypted with AES ECB. It's got 2 counters comprising 3 bytes. It's got a private ID and some other mostly unused stuff inside the OTP. It looks a bit odd. It's not digits at all. it's something called mod hex that maps like that from hex, which is to make it mostly keyboard agnostic. It works on most keyboards without changing any layouts. Validation for the Yubico OTP then. Yep, so you find the correct key with the public ID, as the ID was part of the OTP already. Decrypt it, verify CRC, and you compare the private ID and the counters. So again, it's event-based. You have to store the counter of the token, but you might not have synchronization problems as you could allow for a bigger window since you don't have to test in the same way. Optional look at the timer, but it might wrap, I'm writing, which makes it quite useless. So here we get into the interesting world of using a cloud-based validation. You can, for the Yubico OTP, you can use Yubico's YubiCloud, which is a cloud-based validation service. The downside of that, the big upside of that is that the same key can be used with several services. The downside of using a cloud-based validation is that if a malicious site can tell the user to use its key and will not validate that OTP, but instead save it for use against a legitimate service, which is an interesting challenge. Or you just run the validation on your own, either with components or build it from whatever components you want. So I've talked about oath, HOTP and TOTP. Oath is standard, very good thing about it. It means there are lots of token vendors, there are lots of software tokens available for it. It's a simple algorithm to implement in hardware or software. There's no identification of the token unless you use something called the oath token identifier, which is a 12-character identifier used by almost no one. So you have to compare, either only allow the user to have one token, which is the way some services, typically Google, go, or you allow the user to register multiple tokens, which means you have a bigger surface for guessing the OTP. Since it's just 6 digits, one guess, it's 1 in a million, which is, I mean, it's quite likely that you will hit it. And when you have 3 registered tokens and you have a window of 3 OKRs, then it's 9 in a million. Always hard to know. It depends on what risks you have. There's brute force to think of. If the attacker has gained the password of the user and you don't have a rate limiting on OTPs, GitHub used to not have a rate limiting. They paid out a bounty to the guy that realized that. They allowed for guessing limitless. So that is to consider as well. HOTP. It's simple hardware tokens. You can get cheap hardware tokens for that, which is a good thing, I guess. Though you have the service validating has to have a synchronized database of counters, which for some is makes it a no-go. TOTP, on the other hand, there's no database of counters. It's valid for a limited time, which is an upside if an attacker harvests OTPs from your users. They shouldn't be valid after a minute. Bit more complex hardware with typically a battery or only software authenticators, which again might be okay depending on use cases. Yubico OTP. It comes with with identifications. You don't have to guess what token it is. It's a longer OTP with more entropy in it. It might be guaranteed hardware token, but that is dependent on the manufacturer, so to speak. So it's not really a valid point for the OTP as such. It's not a standard. There used to be another manufacturer of Yubico OTP tokens, but I don't think they ever got any economy into it. The Yumi key existed for a little while. It looked very much like the YubiKey, but with a U on it instead. Again, we're with the synchronized database of counters for the validation, which is not very nice to have to run. I mentioned some stuff on validation in the cloud, and with this, the YubiCloud exists for Yubico OTP. Symantec is running a service they call Symantec VIP for HOTP. You might have heard of the YubiKey VIP that is using the Symantec VIP service. I don't know how available that is in Sweden. I think PayPal is using that in the UK, for example. The big upside of validations in the cloud is, well, when the user has one hardware token, he or she can use that for several sites. So definitely an upside. As I said, if an attacker manages to get OTPs and not validate them, can be replayed at another site at a later time, which is speaking definitely against doing validation in the cloud for high-risk services. And I've written soft multi-credential authenticators, thinking about Google Authenticator, basically. The move seems to be to site local validation for all big internet giants, so to speak. Facebook is running TOTP with doing validation themselves, Google, GitHub, and so on. So more and more think that running it themselves is a good idea. Though you really want redundancy and uptime, which is also where the synchronizing counters gets boring, that you don't want it running on one server and taking down your complete service. Or just logins, I guess, but that's the complete service for most. And you have to think about seed storage. How high risk is the service? With seed storage, I mean the keys, which is like the RSA leak. They leaked the seeds to the tokens somehow, which was later used to attack Lockheed Martin. It's probably best to be completely sure that you are storing the seeds in HSM equivalent hardware, and be sure that they're not at the manufacturer's in clear text online. Well, in a high-risk setting, that is probably a bad idea. So that is what we have now. We have oaths, HOTP and TOTP. I've talked about the Yubico OTP, of course. There's a couple more OTP algorithms like S-key and I'm not coming up with any now. There's a couple more used more and less. The future, according to Yubico, lies in the FIDO Alliance's universal second factor, which is not at all an OTP algorithm. But there's also the oath OKRA, challenge response algorithm, which is interesting at least. U2F. Draft standards was finally published for U2F. How many of you have heard of U2F? Okay, about 5. It's a very new standard. It's the founding members of the U2F working group is Yubico and Google, I'd guess, and NXP. The YubiKey Neo. Have more of you heard of that? A couple more. Yeah, the YubiKey Neo was built for the U2F algorithm, and then we leveraged that to build other things with it. But the U2F has been standardized in the FIDO Alliance, which is a closed group of paying companies building the standard. The algorithm itself is built on asymmetric cryptography. It's nothing hash-based, it's not encryption with a symmetric key. It's an elliptic curve crypto with the NIST P256 curve. It's used. The big selling point of U2F is that it's a hardware token in the original form, but with per service keys. So with an HOTP token or a YubiKey, you have the same key for all services. But for U2F, the idea is to generate a new key pair per service you use it with. So you can't phish the authenticator for an OTP and use that against another service. It contains features for to ensure that you're talking with a hard authenticator. It's unsure. It's up to the validator if they want to check that or not. So the validation service can check if it is a hard authenticator or just not care and be happy that the user is using something, not only passwords. It's got some protection for man in the middle. I'm not going to go through the standard as such, but it's trying to protect against man in the middle. There's problems with man in the browser with it, but man in the middle should be hard at least, or harder. So one of the interesting things with our older two-factor algorithms is that they don't contain an enroll step. The enroll step is out of band. Google has done some work with the QR codes for Google Authenticator that I wouldn't say it's becoming standard, but it's working in several settings, scanning a QR code with a smartphone to get the secret. For the U2F protocol, there is an enroll primitive built in, which generates a key pair for the elliptic curve signature. And that key pair, it's constructed so it might let the service store the key pair in an encrypted fashion. So the token encrypts the key pair to itself and gives that blob to the server to store for it. So you don't have to worry about storage for all your services when this protocol is used everywhere on the internet. So the signature operation takes a few more inputs, but at the basis of it, there is a server challenge and there is a site ID provided by the browser typically. And it signs it with ECDSA with that key. And at the enroll step, it handed over the public key for that key pair to the server. So the server compares that signature or validates that ECDSA signature with the public key. It's very much a browser-centered protocol. The typical API for it is a JavaScript API that is right now implemented with an extension in Chrome, I think. Google claims that it will be integrated, and it will be interesting to see whether the other browsers follow suit there. A big upside of this protocol is that the server doesn't really hold anything secret. It holds a public key. It might have an encrypted key for the user, but nothing identifiable. And there's also no way for the server to discover if the token is registered with another service. So it should be not safe, but it should be lower risk using the same token with your email provider at work and the sleazy web pages, for example. So it's an attempt to build an anonymous authentication protocol there. There's provisions in the standard for presence that there actually is a user present when authenticating or enrolling a token. What presence actually means is something else. For the YubiKey, it means touching the button. For another authenticator, it might mean something else. OKRA. Just looking at the spec of OKRA or looking at what it is, it's a challenge response algorithm based on oath. So the server sends a challenge that is then used as input in the oath algorithm, and you get basically the same output, 6 or 8 digits, used in the same way, but with a server challenge instead of only local stuff from the token. It's got more provisions for SHA-256 or SHA-512. It's not as tied down to SHA-1 as the TOTP and HOTP has become, at least. The interesting thing with OKRA is that 1 year ago, it seemed like it was dead in the water. No one was talking about it. Now, people are talking about it. We get questions now and then about, does the YubiKey support the OKRA protocol? Could you build this? Which is interesting. At least interesting. I've walked through this quite fast, leaving more time for Per, I think. I'm happy to take any questions you might have now.
Yes, this U2F concept, how is that intended to interact with the user? Is it a 6-digit code and how do you key?
No, it's typically intended to interact with the user by having either a hard authenticator plugged into your computer, like the YubiKey, and letting the YubiKey do the operation, so to speak, based on allowing the user to touch to confirm that it wants the signature to go through. So it's intended to interact with an attached device or an out-of-band communication between the computer and another device, like a Bluetooth device or a smartphone with a soft authenticator.
It would require two-way communication, right?
Yes.
Good keys that suit with that?
We think so. Yeah. It's got, we don't have an implementation of the draft standard of the U2F token yet, but we are hoping to build that shortly, to use a non-specific word. And we've had implementations of the U2F earlier drafts of the spec work we have implementations of. And we've sold quite a few of those devices to members of the FIDO Alliance, at least in the hundreds of thousands. So the basis for the U2F work was with the YubiKey, yes.
I own a YubiKey Neo, and from what I understand, it can only use RSA.
No, it happily uses ECC as well. It up to 320-bit ECC. It doesn't seem, well, it's unclear to us exactly what curves it supports. We've got a list of curves that work fine, but we're not sure about what the complete list of supported curves are. But the brain pool curves work, and the NIST's P256 curve work.
But that's dependent on the SIM card.
Yeah.
Okay, you mentioned that Yubico, they have sort of an implementation of early drafts of U2F. Are there any other players in the U2F market?
Yes. We got devices today from a French manufacturer called PlugUp that are supposed to be U2F devices. So yeah, there are a few more I don't know if there is PlugUp that is a token vendor as well in the U2F world, and there are several more chip makers. There is NXP making our chip, and there is Infineon is also in this working group.
What about the backend sort of server support? Are there any libraries available?
Yeah. We pushed a release of Python code supporting U2F today to GitHub.
Okay, and that's about it. Are there any other libraries from other manufacturers and stuff?
Not open source at this time that we know of. But Google has an implementation as well.
Are there any specific reason for implementing IS with electronic output mode?
I don't know, to be honest. That was before my... the YubiKey standard has a very simple CPU, not to call it a CPU even. So the firmware fits in under 8K, if I remember correctly. So it's a very, especially for the later firmware versions, the firmware is very heavily packed into those 8K. And the earliest devices was probably the same way. Yep.
Okay. Have you disclosed the manufacturer of the SIM card?
It's NXP in the Neo.
Okay.
Making it's a chip from them called the A7000X.
Is that on your website?
I don't know, to be honest. I've answered on our forum with a link to that spec.
Yes.
Yep.
You have been talking about those new standards. What about those old legacy RSA and QID?
Yeah. When I started at Yubico 2 years ago, it's not a long time ago, if you said OTP token, people thought of the RSA Secure ID.
Yeah.
That was what was an OTP token 2 years ago. Now it's interesting. When people mention OTP token on Twitter, there might be a link to a YubiKey for that, which is an interesting development in that world, I think. So, and with the latest things around RSA, it seems their name is even worse. Though they are also members of the U2F working group. So it will be interesting to see if there's something new from them as well.
Yeah, it's quite common also with SMS runtime.
Yeah, absolutely.
And they are set only for the session, so they cannot be replayed. So that's the...
Yeah, there's different... Some players implement TOTP over SMS, basically. I think that is what Facebook uses, for example. Either, if you try really hard, you can activate Google Authenticator or similar for Facebook. But standard there is SMS only. But there's... We've not been very interested in the SMS way, but I guess there
I
are...
guess if you have to log in like 10 times a day,
Yeah.
SMS would be a bit boring to type
Yeah.
characters all the time.
There's quite good talk from Facebook where they've just deployed YubiKeys, and they started with SMS based, but they wanted to authenticate all SSH sessions in the company. And some people made hundreds a day at least, and the getting up a cell phone and typing that code from an SMS wasn't the only thing that would mean. If people had to do that, was that they would circumvent the authentication.
Yeah, SSH keys.
Yeah, SSH keys, or they want, well, Facebook added OTP for SSH keys as well.
Yeah, like SARM also with a force command.
Yeah, I think so. So it depends on your use case. If you have to use OTPs seldom, SMS might be a solution. If you want to use SMS often, several times a day, hundreds of times a day, you probably want something that inputs it automatically for you. Very good.
Yeah, perhaps a little bit off topic, but for me, I use my YubiKey every day. Does YubiKey have any? Now the only part is that I can't use it whenever I use my tablet or smartphone. Is there any ideas for Yubico to think about going out to handle those devices at all, or is it only computers that you're focusing on?
The YubiKey Neo has NFC capabilities that work for some Androids and some use cases. We are thinking about it. I think I can say without saying either too much or too little. But yes, absolutely, it's a focus for us. It's a big growing space, and we want to sell things to everyone that has a smartphone and tablet. Yes.
Nothing more.
I read recently, I think last week, that Google bought a company that used audio authentication or ultrasonic authentication. Do you have any input on what's it for?
Only that it's interesting. I don't know. No, I don't have any input as such on that.
Is it possible to disable the NFC on
No. You can probably order and ask for that, but not from a consumer standpoint. It's not possible. Go on.
Okay. The counter on the Yubico Neo is that you know, when you put it in
Yep.
OpenGPG compatible mode, I think there's a counter for how many times you sign.
Yeah.
And that counter is connected to the signing key.
Yeah.
I would love to connect it to the authentication key instead, because then I can see how many times it's been used for SSH connection.
Mail me.
Okay.
It can be done,
Okay.
but with some additional work. Yep, I'll have to leave early, but I'll be here a bit after Per's presentation as well. So just ask if you want, if you have anything to ask, or send an email, or ask on Twitter.